So the big picture for this lesson is special products. So one special pattern if you're multiplying the same binomial twice in a row, it equals x squared plus 2x plus 1. So basically you take the first term and square it, the last term and square it, and then it's 2 times the middle term. That's a special pattern there. If you have like this, same pattern, except the middle term is negative instead of positive. If you have a sum and a difference pattern like this, it's the same binomial, except you're adding the second term in one and subtracting in the second. It's like this. You square the first term, and then you subtract the square of the last term. And all of these can be found using the FOIL method, but if you know these patterns, it's a little shortcut. You just need to be careful that you don't make mistakes with the patterns. And there's also a special pattern for cubing a binomial, and that leads to Pascal's triangle. Pascal's triangle is formed by making 3 ones in a triangle, and then what you do is you take the two numbers that are diagonally above and then add. So 1 plus 1 makes 2, and then you build out the rest with 1s on either side. So for example, this 3 is 1 plus 2, and this 3 is 2 plus 1, and then you put 1s on both sides. And then 3 plus 3 is 6, 1 plus 3 is 4, and so on and so forth. One of the uses of the Pascal's triangle is it tells you what the coefficient is going to be for a binomial expansion. So for example, that special pattern of x squared plus 2x plus 1 I showed you, that's right here, 1, 2, 1. So if I had x plus 1 cubed, it would be 1, 3, 3, 1 would be the pattern. Okay, it'd be like that. And this is the simplest version of the pattern. If you had something like 2x minus 6, for example, then you would be putting the whole term, not just the x. So it would be like this. Okay, so there's a lot going on here. First of all, I want to point out the pattern with the coefficients. 1, 3, 3, and then 1 here, the invisible 1. So then what happens is these first terms count down. So 2x to the third, and then it's 2x squared, and then 2x to the 1, and then 2x to the 0, or just 1. And then the negative 6 counts up. So there's negative 6 to the 0 here, which makes 1, and then negative 6 to the 1 here, which is negative 6, negative 6 squared, and then negative 6 to the third power. So there's a pattern with the exponents as well. And the simplest example is this cubed pattern, but it also increases with the exponents. You can do 4th, 5th, 6th, so on and so forth. But that's the big picture for this lesson, special patterns of multiplication.